So this video is going to look at the triangle distribution, specifically inverse triangle distribution problems. So we know that the formula for a triangle distribution is that our probability is equal to half our base multiplied by our height. So we need to know the base and the height of our triangles to find the probability of our event. We also use the ratio of right angle triangle or similar triangles where h1 over b1 is equal to h2 over b2. The inverse triangle problem usually gives you, or will give you, the probability of an event happening, and it actually usually misses out an x value or the mode itself. So if we're missing our mode, which is represented by x here, we need to make sure that we're able to find it using our similar triangle formulas. So we've got 14 up to 20 with a probability of 0.12 happening, and a full triangle that goes from 2 to 20. So h1 is equal to 2 over the base, which is 20 minus 2, which is 2 over 18, or 1 over 9. So we're going to use h1 as 1 over 9. h2 is can be found by rearranging the formula because we have our probability 0.12. And we can rearrange this to find a height of 0.04. Using our ratio of right angle triangles, we have 3 of the pieces that we need. We have h1, we have h2, and we have b2. Therefore, we can rearrange and find b1. Now, what you need to remember, though, is that b1 is the length of the base. So the length of the base is 16.58. So the x value that we're actually looking for is 20 minus 16.58. So our x value is actually 3.42. If we're to find an x value, so we've been given the mode, we've been given the upper and lower, the minimum and the maximum, and we've been given a probability of the event, it actually gets a little bit trickier. The base of the triangle that we're trying to solve for is 28 minus the value of x, and we're going to use this expression all the way through. We also can find that our height of the full triangle is 1 over 8, and we know that it's 20% or 0.2. So actually what we have here, when we have our h1 over b1 equals h2 over b2, is we have a base expression and we're trying to solve for the height of that triangle. But then what we're going to end up with is, because we have an expression for the base, we're going to end up with an expression for the height also involving x. So we can solve that this way here. We can then use that expression for the base and the expression for the height for the area. To solve for our value of x using the area. So area equals half base times height. So we can rearrange it in this formula. And you can see that we have to multiply in both the 28 and the negative x into the other set of brackets, much like you did in level 1 with quadratics, and much like you expanding brackets, and much like you did at level 2 with expanding brackets if you did the algebra there. And what we find is that we end up with a factorized quadratic, an expanded quadratic. We move the 0.4 into the equation so that it is equal to 0. And then we can solve using the graphics calculator equation solver. If you don't know how to use the graphics calculator equation solver, make sure you let me know and we can go through that. What we end up with, because it is a quadratic, we end up with 2 solutions, where x equals 21.8 or x equals 24.2. However, 21.8 is the only solution that is within the range of our triangle that goes from 12 to 28. So therefore, the solution to this problem is that x equals 21.8.